Hello everyone, welcome to my channel Physics with Bhatt. To learn concepts of physics, subscribe this channel and press the bell icon button to notified of every new video lecture. In the last video lecture, we have discussed about the Young's double slit experiment, how the fringes are formed on the screen, what are the positions of constructive and destructive interferences, and because of constructive and destructive interference, what happens on the screen, that we came to know in the last video. Today, once again, I am here with you to discuss few more things in the same sequence, and that I will talk here about the pattern of fringes, or you can say pattern on the screen which is visible due to constructive and destructive interference. Let us see the diagram here. In this diagram, you can see two patterns are shown. In first look, they appear in the same area, but if you have a minor look towards these two diagrams, then you can see a lot of differences are here. The first diagram is on the scale of 0 to 50 and minus 50, and the second diagram is on the scale of 0 to 10 and minus 10 in the same region. So in first diagram, you can see the fringes are seen little bit curved. These bands you can see here, alternative dark and bright bands are seen. So these bright and dark bands are produced or formed just because of constructive and destructive interferences taking place on various places of the screen. In the first diagram, we have the you can say large area view, and in second diagram we have the particular section. Out of these 50 minus 50, we have only 10 millimeter on both the sides of center of the screen. This point O is not 0, it is center of the screen in both the diagrams. So what is the difference in these two? That is very important to understand. In reality, the bands are formed in curved form like rings, but since their radii are very large, so a small section of this particular pattern appears to be linear, that is straight bands you can see here. So wherever you are seeing the white lines, these are representing constructive interferences, and the dark lines, these black lines, are representing destructive interferences. So in the last video lecture, we came to know about the positions, that at what position the bright band will form and at what position the dark band will form, and how can we find the positions on the screen by using the given formula. In this section, we will talk about the bandwidth of these two, bright and dark, and we will try to understand the pattern obtained on the screen. As you can see here in both the diagrams, they are similar diagrams. They are the diagrams of the same screen with different scales. So O is the center and center is bright. So we can say center of the screen is bright. After that, alternative dark and bright beds are seen. Every bright band is between two consecutive dark bands. Every dark band is between two consecutive bright bands. So this is the brief illustration of the fringe pattern or the band pattern obtained on the screen, and you can see center of the screen is bright. After that center, alternative dark and bright bands are seen. Every bright band is between two consecutive dark bands, and every dark band is between two consecutive bright bands. We will talk here about the bandwidth of first of all, we will talk about bandwidth of bright fringe, then we will talk about bandwidth of dark fringes, and then we will talk about bandwidth of central bright fringe. So bandwidth of bright fringe, if you want to find bandwidth of bright fringe, then we have to go through the pattern on the screen, and we can say every bright is lying between two consecutive dark. So separation between two consecutive dark bands would be equal to bandwidth of the bright band. This we denote by beta. So beta is equal to y dash n plus 1 minus y dash n, where these two are the positions of two consecutive dark bands on the screen. Y dash n is equal to 2n plus 1 lambda d upon 2d. This is the position of formula for position of the dark band, and y dash n plus 1 would be 2 n plus 1 into lambda d upon 2d. What we have done, we have taken n plus 1 in place of n. Then beta is equal to two n plus 1 lambda d upon 2d minus 2n plus 1 lambda d upon 2d. So what is common here? If you open the bracket, it will be 2n plus 1, 2n plus 2 plus 1 lambda d upon 2d minus 2n plus 1 lambda d upon 2d. If you take out 2n plus 3 minus 2n minus 1 lambda d upon 2d. So what we have done, we have taken lambda d upon 2d as a common. So from the first bracket we have 2n plus 3, and from the second bracket we have minus 2n plus 1. If you open the bracket, it will be minus 2n minus 1. So minus 2n minus 2n will be cancelled. So it comes to 3 minus 1 lambda d upon 2d, and 3 minus 1 is 2 lambda d upon 2d. If you cancel 2, it comes to beta is equal to lambda d upon d. In the similar way, we can find the width of dark band also. So this is what width of bright bands. So all the bright bands would be of the width lambda d upon d. Similarly, we can find width of dark bands. Since every dark band is lying between two consecutive bright bands, so separation between two consecutive bright bands, separation between two consecutive bright bands. How can we find this? It is noted by beta dash, and beta dash is equal to yn plus 1 minus yn. Here yn and yn plus 1 are the positions of two consecutive bright bands. Yn is equal to n lambda d upon d, and yn plus 1 is equal to n plus 1 lambda d upon d. Then beta dash is equal to n plus 1 lambda d upon d minus n lambda d upon d. So lambda d upon d is common. So from the first bracket it is n plus 1 minus n lambda d upon d. It implies beta dash is equal to lambda d upon d. So this is width of dark bands. All the dark bands are of width lambda d upon d. You can see this formula is similar to the width of bright bands also. Then it comes to width of central bright band. Width of, in the same sequence we will consider another one, that is width of central bright band. This central bright band is between first dark band on either side of the center of screen. Therefore, width of central bright would be y1 dash plus y1 dash. So y1 dash is position of first dark band on upper side or left side of the center of the screen, and y1 dash is on other side, that is below or right side of the screen. We can take horizontal and vertical aspects both. To find y1 dash, we will use the formula of dark positions, that is y dash n is equal to 2n plus 1 lambda d upon 2d. To find the position of first dark band, we have to replace n is equal to 0, so y1 dash is equal to lambda d upon 2d. Then beta naught is equal to lambda d upon 2d plus lambda d upon 2d. So it comes to beta naught is equal to lambda d upon d. This is what width of central bright band. So we can see that all the fringes, all the bands are sometimes written as fringes also. All the fringes are of identical in width, and that is beta is equal to beta dash is equal to beta naught is equal to lambda d upon d. So in this video lecture, I tried to explain you about the fringe pattern or bands in Young's double slit experiment of interference, that what kind of pattern we see on the screen, and what are the you can say width of these individual bands, central bright band, then secondary bright bands, and then the dark bands on the screen. Thanks for watching. We will meet in the next video lecture very soon. Keep watching, keep learning.